Assalamualaikum and hi everyone. So this diagram shows a BJT common emitter amplifier, and this amplifier has a voltage divider by a circuit. The beta value for this circuit is 96. The first question requires us to perform DC analysis to calculate the DC operating point, VCEQ and ICQ. During the DC analysis, the capacitors and the AC source in the circuit will be open circuit. The 100 kilo ohm resistor and 25 kilo ohm resistor will be combined. Hence, the equivalent DC circuit will be as follows. There are two loops that we gain from the redrawn circuit. Before we apply the Kirchhoff's voltage law, find the value of VTH and RTH first. The VTH can be calculated using the formula R2 over R1 plus R2 times with VCC. We will get the value of VTH as 3 volt. Next, the RTH value is the parallel combination of the 100k ohm and 25k ohm resistors, which is equal to 20k ohm. Now, we can apply Kirchhoff's law to the first loop. We will get negative 3 plus IB times 20k plus VBE plus IE times 1k equals to 0. IE is also equals to 1 plus beta times IB. Substitute the IE expression into the equation. Insert all the known values in the equation and we will find that IB is equals to 19.66 microampere. Now that you have found the value of IB, we can find the value of ICQ. ICQ is approximately equal to IE. Hence, the value of ICQ is 1.91 milliampere. Next, apply the Kirchhoff's law to the second loop and we will get VCE as 8.89 volt. The second question asks us to perform AC analysis to calculate the small signal parameters GM and RBE. Just now we have performed the DC analysis and obtained the value of IC. So, we can directly calculate GM and RBE values using the formula IC over VT and VT over IC respectively. VT is a constant with a value of 0.026. We will get the value of GM as 73.46 milliampere per volt and RBE as 13.61 ohm. The third question requires us to sketch the small signal equivalent circuit for the amplifier. During AC analysis, the capacitor will be short circuit, while the DC source will be open circuit. In the circuit, there is one resistor that is parallel to a short circuit, so the resistor will also turn into a short circuit. There are two types of models that we can use to sketch the circuit: T model and hybrid pi model. The sketch shown is a hybrid pi model. Notice that the emitter resistor is not present as it has become short circuit. Lastly, the question asks us to calculate the voltage gain of the circuit. As we know, voltage gain is equal to V output over Vs. We can start off by calculating the V output. V output is equals to negative IC times RC parallel to RL, which is also equals to negative GM times V pi times RC parallel to RL. Substitute the known values in the formula and we will get an expression of VO equals to negative 132.228 V pi. We have to calculate the value of V pi first. As you can see in the left side of the circuit, it is actually a voltage divider circuit. Hence, we can find the value of V pi using the voltage divider formula. R input is the parallel combination of RTH and R pi. R pi is equals to beta over Gm. We will get the value of R input as 1.229 k ohm. Substitute the values of R input and Rs into the formula of V pi, and we will get an expression of V pi in terms of Vs. Substitute the expression of V pi into the expression of V input, V output, and divide with Vs to calculate the voltage gain. As the final answer, the voltage gain is negative 72.91.